My name is Arvind Shyamsundar. I am Principal Program Manager at Microsoft, and it is my pleasure to be presenting this session to you. A quick word about myself if you're interested. I have been at Microsoft for a while now, and I have been working on SQL, on Microsoft SQL family of products and services for even longer. I come with a lot of experience in the field, and last couple of years have been with the product teams, working very closely with our customers and making sure our products and services function the way our customers want them to function. As a quick reminder or a quick pointer, a lot of the source code that I'm going to show you today is on GitHub under my organization, if you may. It's called github.com, Arvind at Microsoft. And if you want to follow up on questions, of course use the chat feature in this conference. I'm available for Q&A after the session, and you can always contact me on Twitter, which is where I do keep monitoring for questions and follow up. So my Twitter handle is ARVISAM, and that's where you can find me. So ideally, as I said, a lot of this code is available because we are going to be looking at code. We are going to be looking at infrastructure as code, if you may, databases as code, and then some C# code, if time permits. So the repo that you can use for follow-up investigations, and if you want to try along with us, please visit github.com. This URL is where all the source code for these demos are. And to make the most of this session, we do expect that you have some prior knowledge of Azure SQL, specifically Azure SQL Database, because that is the target environment for most of our demos today. And you have some knowledge of T-SQL. Obviously, that I think that is may sound cliche, but we do expect that as a background. If you're a .NET developer, it may really help if you are looking at some of the specific things around GitHub Actions, DBHub, but it's not necessary. And we do assume that you are at least somewhat aware of source control, Git. It's kind of a standard today in most use cases. We will not be getting into very specific recommendations. As you will see in the slides that follow, the main intent in this session is to give you the landscape, the broader view on what DevOps means and what does it mean for SQL, for Azure SQL specifically. So we will emphasize the breadth of offerings, the choices that you have, and give you some of the considerations that you can apply to make the choice relevant to your organization, to your scenarios. We will not be prescribing, hey, this is the one thing that you will be doing. That said, I do want to give a shout out. There is a related presentation on database projects or SQL projects, which is being done by Drew and Udisha from Microsoft at this conference. I will have a link to that session towards the end of my presentation. Do go to that session if you're very interested in looking at SQL projects. And specifically, this is the stuff that classically we have referred to as SSDT, DAC packs, and all the good stuff there. So they have a deep dive into the development experience around DAC packs, SQL projects separately. Just as a kind of a precursor to this session, we are going to be focused on the breadth and the choices available to us in terms of DevOps tools and technologies for Azure SQL. We like to break down DevOps into four distinct phases or sets of activities. And these are the plan phase. The plan phase is roughly around your overall software process, like Agile, Scrum, so on. You have your entire backlog, the iterations that you have in terms of sprints and so on. So all of that goes into the planning phase. Then we have development. Development is actually where you write the code, and today databases are 100% treated as code. It is not something which lives in isolation. So the development phase is where you land your code, where you make changes to the database structure. And the important thing, again, as I want to emphasize, is databases are code. We want to treat that just like any other application code. Infrastructure as code in a broader sense is a well accepted concept and practice today. So we want to emphasize that databases are also part of that, understanding and treatment as code. Then comes the deliver step, where we actually take those changes, take the code that was built as part of your database, and deliver it to an environment which is your production environment or your dev test environment. You may have workflows around this. You may want to have automation. You may also want to have approvals and so on and so forth. And the key point here, which we will emphasize in our walkthroughs and slides, is to ensure that this step, which is the deliver step, is as we want to have minimal human intervention in it. As far as possible, most of this should be automated. It should be in the context of service principal or some kind of an identity which is not a human being. We want to avoid human errors as much as possible in this step. And then comes the operate step, which I briefly alluded to earlier in this talk, or in setting context for this talk, which is a huge bucket in itself. The operate is where you actually look at the system, monitor what's going on, react to events. So you may have errors, you may have some performance things which are going on. You want to react to that, iteratively tune stuff. So you may find things in production which need to be addressed, and that will typically go into your backlog and you start afresh. So you go back to your backlog, schedule these, assign the tasks to the development team, which is also the database development team today, and then you start all over again, right? This is a continuous chain of plan, develop, deliver, operate. If you would break this down a little bit more into these two quadrants, which we briefly talked about, there are a couple of things that I want to emphasize. One is the fact that with develop, we have a lot of, if you break that down into discrete activities or aspects, there are certain things that I have alluded to, but just formally representing them again. Um, Source code control, version control for the database objects that we are developing, very, very important. Uh, Collaboration with developers. Today, you very rarely will have just one person writing all the code in the system. It's not at all the case. It's typically a bigger team. Uh, they all have to come together. There are approvals in place, code reviews, and so on and so forth. So how do you support all of that in a system is going to be the key thing. Then ideally you want to have checks. So I don't want to write code which is going to have production issues. Ideally, I want to detect any code quality problems with that piece of code well ahead of time, at the time I'm writing the code itself rather than after it's deployed, so on and so forth. So these are some of the aspects that we will see are important when it comes to selecting tools for development. And then there's the deliver piece, as we alluded to, is the actual activity around taking your code and deploying it onto a target environment. In this case, what we will see typically is the importance of aligning with frameworks. And your organization may have a higher level set of standards which are to use a particular set of tools. You may have security requirements that you need to meet. You may have to use certain predefined templates for deploying databases and so on and so forth. So alignment and at the same time being able to customize to those requirements is going to be one of the key things. Other things that are very, very important is you don't want the same script. If it's delivered twice, for example, or let's just generalize that to, you do not want a change to kind of error out if it happened to be delivered twice to the same target environment. You want those changes to be idempotent. Idempotency is a very important requirement in most modern pipelines, in most modern deployment frameworks. You will see that it is a mandatory thing, wherein if the same change is done and happens to be delivered twice, it becomes effectively a no-op operation. So these are some of the kind of requirements that we want to address with these frameworks. And the the most important thing is to be aware of what options you have in terms of tooling, processes, and frameworks to meet some of these requirements. So let's take a look at some of those. Okay, so with that background on the four distinct phases, we saw plan, we saw develop, we saw deliver, and then we saw operate. And you remember that it is all a cycle. So the next few slides, I want to just kind of deep dive into some of these very quickly in terms of options that you have. And again, as I said in the beginning of the presentation, we are not going to prescribe one specific architecture or one specific tool. It is important to know the choices available, because in the end of the day, you have to snap to whatever your organization or your team wants to use. And in the end of the day, knowing these things in terms of choices is very, very important if when you're deciding. So if you look at the first phase, which is plan is a distinct bucket in itself. We'll come to that in a minute. But most of the time, you're starting from, as a dev, you're typically concerned with the develop phase, and development is a very, very important piece of the pie. So from as I mentioned to you, uh, we have many, many options. Some of you are probably familiar with this kind of very popular option called SSDT. SSDT is formally known today as SQL projects, and it's a part of Visual Studio, which means it's Windows only. But we also have now Azure Data Studio having SQL project support. And as I mentioned in this conference, we have our colleagues Drew and Udisha talking about the new SQL project support in Azure Data Studio. So do go to that session if you're interested to see how you can build a DAC pack, for example, and how you can have a SQL project ecosystem with Azure Data Studio. You also have Visual Studio Code, which you will see is an option as well if you want to develop projects which are more change-based, for example, in approach. And then you have, of course, Management Studio, which is still a viable kind of a development option, especially if you combine it with some of these third-party offerings, which offer more rich development experience. Some of these third-party offerings also allow you to integrate Management Studio with source code control and so on and so forth. For most of our purposes today, I'm going to be focusing on how you can use Visual Studio for database development, and we will use DAC packs and Azure DevOps later to actually put all this together. Now, a key thing to emphasize here is approach of database development. So there are two approaches that I want to summarize. There is this approach that Visual Studio SQL Projects takes, which is what we call a declarative approach, or a state-based approach, as it's sometimes referred to. And then there is another approach, which is kind of, in my opinion, the classic approach, which is change-based or migration-based approaches. Change or migration-based approaches are based on the philosophy that the developer will specify how to change the state of the database. Whereas if you look at Visual Studio, as you'll see in the later demos, if I want to make a change there, I don't specify how. I specify what the destination or the target should be. To put this into perspective, again, it's kind of easy to imagine if you correlate this to the analogy of a pizza. Let's say you like pizza and you want to eat pizza, and you have two options, right? You can order pizza, which is quite common, or you can bake your own pizza at home. Uh, your, and you can contrast these two approaches. If you are going to order a pizza, it's quite simple. You just typically pick up your phone, call someone, call the pizza place of your choice, or in the modern world, you'll use an app of some sort to order pizza. You specify what you want, and then within half an hour or whatever, you'll typically have your pizza at your place. The challenges here are sometimes you may not get exactly what you wanted. Like the choices might be kind of limited. Like let's say you like a wheat base and they don't have a wheat base option. So be it. You have to stick to what they have. But then the beauty of it is you don't have to do much. You just order and it's there. If you order a pizza, think of that as the metaphor or the example of what I refer to as a declarative approach to database development. You just declare that I want this table to look like this. I want this stored procedure to look like this. And then the tooling behind the scenes figures out how to change the database itself, how to alter the database to get to that state. So again, as a reminder, declarative is what SQL projects or DAC packs allow you to do. So it is a declarative based approach. On the other hand, you have imperative based approaches or change based or migration based approaches. It's kind of similar terms, but they mean the same thing. So in the imperative approach, it is like the other option in the pizza analogy, wherein you build your own, you make your own pizza. It takes a little bit more time. Sometimes you can get it wrong because you may not be very familiar with making a pizza, maybe sometimes. But the beauty of it is you can make exactly what you want. So like a wheat-based pizza, sure, you buy the ingredients, you make that base, you get your wheat base for the pizza. You want specific toppings, you buy those toppings, you make the pizza just like what you wanted. So the key thing in this approach is more effort on the person part. They have to invest a lot of time and energy to make the pizza, but it's like very satisfying in that sense, wherein you get exactly what you wanted most of the time. Sometimes you can go wrong. Sometimes you may not be able to get the pizza, or you might bake it for too long and it gets burnt. You get the picture. So as a reminder, this is the analogy that I used for the other approach, which is imperative based approaches or migration based approaches or change based approaches. So it's kind of like three different terms for the same thing. So this is what some of these other tools use, like dbup, Flyway are, for example, two tools that use this migration based or change based approach to database development. In these approaches, you have to specify the alter set, the set of alter statements effectively to change the state of a database from one place to the other. You also have to keep track of the fact that a change was already done, so you don't need to do it again. All of this has to be done by the developer. And this is classically what we used to do many years ago, like 15, 20 years ago. Database would be maintained as a set of change scripts. So you have a baseline set of scripts which has the create table, and then a set of alters or additional creates if you added new objects and so on. So just to recap, you have two different options in terms of this methodology or approach. You have declarative, which is Visual Studio, DACPack, SSTT, call it what you want, wherein you just specify the end state. And then there's the other option, which is typically emphasized by these tools like Flyway or dbup, wherein you have to incrementally specify the set of changes that are needed to move a database through its life cycle. So both approaches are completely valid, and they both have their fan base, if you may. And it's we will compare and contrast briefly, but in the end of the day, you have to select what works best for you. Typically, that means comfort level. It means alignment with the other tools, organizational standards, and so on. And then there are multiple commercial tools which are available as well. Some of these options are well known. Again, Microsoft, we do not want to recommend a specific tool because, as I said, again, this is completely your choice. But do be aware that there are multiple choices in the commercial space as well. When it comes to writing code, you have to be able to test it. And I'll very briefly go over this because it could be another session in itself. This is not at all a comprehensive listing of what you will need to do from a database testing point of view. But at a very basic level, if you wanted to test database code, what you need is you need a framework of sorts to be able to run these tests. But more importantly, you need some kind of synthetic test data generation. The key thing I want to emphasize are that for test data generation, there are some very popular third-party or open source options which are available today. One of my personal favorites is this tool called Bogus. Bogus is a .NET tool, .NET library more precisely, and it can be used to generate synthetic data. You also have some commercial options like from certain vendors, and the Visual Studio Test is another option as well. T-SQL-T, these are all frameworks. So then there are many frameworks, but in the end of the day, it comes down to how you implement your test. You need synthetic test data to be able to reliably simulate the situation that the unit test has to run within, and you need the orchestrating framework. So again, this is potentially a big topic in itself. So I don't think I can do justice to it in a big session, in a broader session like this. So just be aware that you have to select your framework, and test data plays a very important role overall in this as well. The next thing we're going to look at is, looking at your code. Again, if you were in the develop bucket, so we are still in the develop bucket of that four quadrant picture, if you recall. And again, there, another important thing is, how do you validate your code before it shows up in production? This is something, again, you should keep in mind when you're selecting tools and approaches. In the migration-based schemes, typically when you use DBUp or Flyway, for example, because you are incrementally specifying the changes in terms of alter scripts and so on, it's kind of hard to get the consolidated picture of what the database looks at any given point in time, because you're expressing the state of the project as a set of changes, and it's kind of hard to pull it all together. But it can be done, typically by doing testing and so on. Uh, Whereas if you have a declarative approach, such as what is taken by SQL projects within Visual Studio or SSTT, in that case, the state of the project is always known to the tool. For example, a DAC pack can be built at any given point in time with Visual Studio or with Azure Data Studio SQL projects. And that DAC pack can therefore represent the complete state of the database at any given point in time. Um, and that is where some of the powerful capabilities for these tools start coming into play. So with Visual Studio SQL projects, or SSTT as it used to be called, you have this thing called code analysis. Code analysis is like code review, but it's done by automation. It's done by the tool itself. Um, this has been, in my opinion, one of the most powerful capabilities within the SQL project. Apart from the fact that it's treated as a project, all up, the fact that you can analyze the code and flag certain anti-patterns is very important. We will see this in a demo which comes up a little later. The other thing I wanted to point out is that there are many samples on GitHub which we make available as part of the DAC extensions project, and from third party and open source contributors. So these other projects that I have here, like T-SQL Smells, Rules, and this other project here, are all contributed by community people, which is great because you have open source kind of movement around it. At the same time, they're not officially supported by Microsoft, but they work very well, for most purposes. So there could be bugs, but most of the time these are fairly useful, and they're free. They're open source, so it's pretty useful to try these out and see what works for you. If you're working with just a plain, sort of set of SQL scripts, then there are some open source analyzers which can operate on those kind of scripts as well. So there is this utility called SQL Check, again on GitHub. All of these links are in the presentation. And certain commercial tools as well. Again, I do not make a specific recommendation or sort of compare all of these, because they're options for you. Out of the box from Microsoft, I think the SQL projects ecosystem is perhaps the most mature in this space from a code analysis point of view. But again, requirements and capabilities will vary depending on your scenario. Moving on, let's look at what options are quite popular for the deliver bucket. So so far we have been looking at the development bucket, right? Like we saw plan, develop, deliver, operate. So we didn't do much justice to plan, and we most of the time looked at develop so far. So let's take a look quickly at what's available as far as deliver is concerned, but also briefly plan. Because most of these platforms have a bit of both, plan and deliver. So I will talk mostly about first party because being from Microsoft, I can perhaps talk best about what we offer. So we're going to look at Azure DevOps, which is our platform of choice many times uh, for a lot of these phases that we saw in the DevOps lifecycle. So you can do with Azure DevOps almost everything that was shown in that quadrant. You can do plan, you can do develop in the form of source code control, you can do pull requests, and the whole typical set of capabilities that you need. You can do pipelines, which is a key part of the deliver bucket. So you can actually take a series of actions or activities or tasks and actually deliver your changes to the target database. So we'll see how that comes together in some demos. We will also have a brief look at GitHub Actions, which is the other first party service. So many of you probably know this, but GitHub is also a Microsoft company today, and we pay a lot of importance to the fact that we want to integrate 100% with the GitHub ecosystem. So GitHub has something called actions, and specifically, these are again, in very simple terms, tasks that allow you to change or to implement a change to a database by running certain commands and so on. So, we'll briefly take a look at this in some detail later on. Again, the whole third party space is rich in this area. So there are many platforms like these vendors out here, and infrastructure as code when it comes to making things which are not necessarily database specific. Like if you wanted to create a SQL server, a logical SQL Server instance in Azure, you may need to use things which are outside of the database. So typically you'll use ARM template, or you might use Azure CLI, or you can use some third-party products like Terraform, Ansible are very popular and commonly requested options. The good news is all of these, Terraform and Ansible especially, have quite tight integration with Azure SQL, and you can have broader set of capabilities also exposed by them. So we'll not deep dive into these third-party tools for today, but we will deep dive into Azure DevOps and in part of our demo, and also briefly look at GitHub Actions later in this presentation. So putting all of this together, another way to look at it in the deliver bucket is, if you wanted to look at it as a tasks view or a task-oriented view, if you may. Wherein on the left-hand column here, we have a set of typical tasks or activities that we may want to perform. And on the right side, you have a set of options. These are not by any means the complete set of options to fulfill this requirement, but it is most likely the set of most popular options, if you may. And you will see some of this in the demo. So we have here a task which says, oh, I want to create a logical server for my Azure SQL databases. I can do that through a variety of means. I can use ARM, I can use AzureCLI, which is what we're going to use in our pipeline in the demo. We can also use third-party tools, as I mentioned to you, Ansible, Terraform, and so on. Like this, there are other steps that we can map to tools. So, for example, to create a database itself, you could do it through T-SQL, which is very common. But then what if you wanted to control certain aspects which are not necessarily exposed in T-SQL? For example, you want to place the database into a pool or an elastic pool at the time of creation. You could perhaps do that most efficiently through AZCLI or something of that sort. So I think in the demo, I'm going to be using AZCLI to create both the logical SQL Server and the Azure SQL DB as well. And you'll see that in action in a few minutes. Then in the demo, I'm going to be mostly centered on this declarative methodology or approach to developing databases. So we're going to be using SQL projects, and there we'll build this thing called a DAC pack, which is kind of like the compiled version of our database. It's the representing the current state of the database. For that, we're going to use something called MS Build, which is a way to compile the project as part of the pipeline. Again, all of this will make more sense when we look at the demo. So running quickly through this, when you actually deploy the DAC pack to a database, you have a underlying set of tools called DACFX. Sometimes, more popularly known as the command line tool, which it is, kind of exposing, which is called SQL package. The good thing is all of the complexity of the tooling is somewhat abstracted by inbuilt actions that come with or activities or tasks that come with Azure DevOps. So we will be using this thing called a SQL deployment task, which ships with Azure DevOps itself to actually deploy the database using a backpack. And then there could be other scenarios where you want to import backpack, for example, instead of working with backpacks and so on. There are many ways you can use AZCLI. So the beautiful thing is within an Azure DevOps pipeline, you can do all of this, in one interface, in one kind of logical pipeline. So with that, let's take a quick initial look at a demo which shows you what Azure DevOps is all about. Uh, to do this, let's actually start from the very basics. So I have here an Azure DevOps organization, as it's called. In this case, it's just called Azure SQL DevOps. So this name is the name of an organization. Within the organization, I can have multiple projects. In this case, I just created a project called e-commerce. It just has a representative name. It doesn't really, don't read too much into the name. The key thing I want to show you in this quick walkthrough of Azure DevOps is that you have um, the four quadrants that we talked about earlier in the beginning of this presentation. We have options to implement a lot of that through Azure DevOps. So Azure DevOps offers this thing called boards, where you can have your backlog. So I'm just going to quickly take a look at that. And the backlogs is the set of user stories, tasks. In this case, I've structured it as a project which has user stories and tasks. And these tasks can be assigned to developers. So in this case, it's assigned to this person called an Azure DevOps SQL DevOps admin. This is a full-featured project planning and execution interface. So you have user stories, you have sprints, which are depicted here in the story. You have tasks, you can assign tasks, and so on and so forth. So that's the planning uh, sort of quadrant, if you may, in this place called the boards. The next thing I want to show you is repos. So source code control, and typically in this case, source code control in the form of a Git repository is implemented by this part of Azure DevOps, which is called repos. Within repos, you can have one or more repos within the same project. And so again, remember, there's an organization, there's a project, and then you have repos. And then each repo can have branches. So in this case, you will see here, I have multiple branches for this particular repo called fitness, which is where I'm going to be working for the rest of the demo. And you can also have pull requests. So we'll take a quick look at this in detail later, but you have pull requests, you have other things that you can do with source control out there. So that's the second big bucket, which is like the develop bucket that we saw. So we saw plan, which is boards, develop, which is um, the repos, and then you have deliver, which is pipelines. So we're going to take a look at pipeline in detail in a minute, but for now, just be aware that you have a rich YAML-based interface for defining and developing pipelines. Pipelines are a set of activities that you can use to deploy, in this case, deploy a database, but it can be used to do a variety of other things. We will deep dive into this in a minute when we come back to the overall flow. So we saw three out of the four big buckets. I'm not going to operate right now, but you can, you can integrate this with other tools which may make, your operation side more convenient. But that was kind of like a whirlwind tour of Azure DevOps. In this case, the demo is going to center around a database, of course, but the database internally is powering a simple demonstration app, which is actually a fitness tracking uh, kind of scenario where we have a REST API, which is pulling data from a database, and that's fitness tracking data. So imagine you have a fitness device on your wrist. It tracks your body temperature. Let's say it tracks various metrics, and you wanted to additionally add a new metric for tracking your body temperature. And that's kind of the scenario that we're going to center on, wherein we have some existing functionality. We want to add new functionality, which is to track temperature. So high level, we have an app that's a .NET based app that's exposing a REST API. It's using Azure SQL database as the backend, And then all our deployments to this database are done through the declarative mechanism, which is you tell the database where it should end at or where it should be, and then the tooling, uh, in this case Visual Studio SQL projects, DAC, FX, and SQL package are going to figure out the how it will get there. All the source code for this project is going to be recorded in Azure DevOps in a repo that you saw earlier as part of the quick walk around Azure DevOps. Now, if you look at some of the details behind this, and what makes this demo a little bit more interesting is that we are going to use a virtual network in Azure, which is private in the sense there is no external connectivity to that Azure SQL DB from the public internet. It is only accessible from within a secured virtual network within Azure. So this also, therefore, prompts certain challenges or certain additional requirements. For this setup to integrate with Azure DevOps, we need to have a self-hosted Azure DevOps agent, which will be in the same VNet as the SQL database is connected to. And that build agent in itself will be able to talk to Azure DevOps in an outgoing manner. So the interesting thing, the key message I want to leave you before we get into the demo is that while we have a fairly simple, straightforward scenario of adding a simple column to a table, but using Visual Studio SQL projects, uh, the things that make this kind of unique are how we orchestrate the actual deployment of this database into the virtual network and so on and so forth. So let's take a quick look of how all of this comes together in the form of a demo. The good thing is that this project is actually able to fully understand the fact that it is not only a column but that it has references from other parts of the project. So this is very, very powerful because if you think about it, being able to resolve the dependency objects that have a dependency on this particular column within the table, if I actually click on any of these, the great thing is that it will actually take me right to the place. So in this case, as you can see, this has taken me to a stored procedure where we have a reference to distance. You can build this project just as you would build any other project. I want to do that in a minute and then show you what's produced as the output. So when you build this project, it actually produces something called a DAC pack. So what the build process does in SQL projects in Visual Studio is it validates your project. It sees if you have any incomplete or missing references to objects that don't exist and so on. It might warn you about some of those. And in the end of the day, it produces this DAC pack. The DAC pack is a self-contained unit. It contains the complete state of your database. That means all tables, stored procedures, views, etc. Anything that's schema related is in the project. The other thing that DAC packs also contain are so-called post and pre-deployment scripts. So as you can see here, it's a little tiny, so let me zoom in. You have a script here, which is reference data. So not only do you have objects in the project, but you can also have reference data. And the reference data here will need to be idempotent in the sense if there is already reference data, you don't want to do it again. So in this case, it's a very simple idempotency check. The other things, if you've not worked with SQL projects, are that you can run something called code analysis. Code analysis is an optional is an optional thing, but what I've done here is I've actually installed a bunch of third-party rules which I can select or deselect depending on my preferences, because there are a lot of rules in this open source project from GitHub, which I may or may not necessarily want for my purposes. And these are the same projects that I had linked to in my slides earlier. So feel free to leverage them, evaluate them, and adopt them if you see them being useful for your purposes. So the way you run code analysis is you can actually do right click and say run code analysis. And the good thing is it's actually going to pop up a lot of very interesting findings. So in this case, it found errors which say that, hey, you got a constraint which is like a primary key constraint and it's not named. Now, if you've been working with SQL for a while, you know that some of these are anti-patterns, wherein you have unnamed constraints. Constraints without a name are not generally considered good practice. So, in my opinion, this is one of the strong differentiating factors which you should consider when you're selecting tools and approaches. The declarative approach that SQL projects offers um, is boosted further by these great capabilities of code analysis. So it's something to consider when you are deciding on an approach. So this kind of is the develop bucket, right, for our project. So we're using SQL projects. We're using Visual Studio in this case. Again, as I said, there's another session in this conference where Drew and Udisha are going to talk about Azure Data Studio. And one of the newly added capabilities in preview in Azure Data Studio is the ability to do similar development experience for database or SQL projects. Um, you can go to their session to take a look at that in detail. I want to take a quick look at the pipeline though. So we saw the develop bucket. We also have to look at the deliver bucket. The deliver is the pipeline. In this case, it is the way that we actually take the changes or take the project that's in source code control, build it, and actually deploy it. I'm going to kind of give an overview because there's actually a lot of detail here. So this is a pipeline which has been defined as part of the project itself. So it is in the repo, it's in a branch, which is called add pipeline env, and the file is a YAML file, as is the standard for a lot of these infrastructure as a code approaches. This is within Azure DevOps. We are within the pipeline section. You will develop this pipeline either in the Azure DevOps UI on the web, or you can actually develop it in a tool like Visual Studio and then push it to Git. And then Azure DevOps can be used to set up a pipeline which leverages the same YAML file. So this pipeline has a number of interesting things which I just want to call out at this point at a summary level. We have a blog post that actually details a lot of this in more detail. So I'll show you that in a minute. But the key thing is to note that, hey, this pipeline is going to be triggered on a pull request. Anytime there's a new pull request to master, this pipeline is going to trigger. The pipeline uses some variables which are mostly used to parameterize the execution so that we don't hardcode anything. Some of it is responsible for managing secrets like username, like passwords, the database name, the server name, and so on. Some of it is related to the type of deployment that we want to do. We want to build a release project as compared to a debug project and so on. This pipeline uses something called multiple stages. So Azure DevOps has this beautiful capability called multi-stage pipelines. Multi-stage pipelines are a very powerful way to orchestrate a complex workflow which spans not only different steps, but it can actually span different environments, different runners actually which are doing the work. And in this case, we are using three distinct stages. The first stage is to actually create a database. So it creates a database, it creates a database using the Azure CLI in this case. And it does that by using an Ubuntu machine. And there's a point in doing this. I'll talk about it in a minute. The second stage builds the DAC pack from the SQL project that we pushed to source control. It builds it using something called VS Build, which is another type of task within Azure DevOps. This is equivalent to the developer doing a right-click build, but because there's no developer in the pipeline, it is an unattended build of the project. The project is then output of that project build is then published as an artifact. So that means the DAC pack is saved to a store within Azure DevOps itself. At the last stage, we deploy the database using the DAC pack that was produced in the previous build DAC pack stage. The deployment of the database uses a special task that is built into Azure DevOps, and it's called Azure SQL Azure DAC pack deployment. This is linked to in the materials in the slide deck if you want to take a further look at the various parameters that it uses. So at a high level, I wanted to emphasize This is a multi-stage pipeline. It uses variables for avoiding hard coding secrets. It is triggered anytime there's a pull request. And the three stages that we have are to create the database, to build the DAC pack, and then to finally deploy the DAC pack to the database. Let's quickly look at some of the supporting constructs within Azure DevOps which make this pipeline actually run. So you see these variables, right? So the variables, where are they declared? So those are actually declared inside a library construct. The library is a place where you can populate variables. So in this case, you can see there are a couple of variable names. Not going to obviously show you the secrets behind the scenes, but you can see that all the variables that we have referenced within the pipeline are actually deployed within the library. The other things I want to show you are the fact that we are using Azure CLI. And if you recall briefly, I talked about this particular stage using a job that's actually running on an Ubuntu VM. You may ask why. The Ubuntu VM is just to showcase that you can run different stages or different jobs uh, on different types of virtual machines. So in this case, just to prove a point, I ran it on an Ubuntu VM, which is in turn using an Azure CLI connection. And what this step is doing is it's actually creating the database. And it does that by using the AZSQL DB create command. The good thing about this particular command is that it is an idempotent command. So if it is rerun and the database already exists, it just doesn't do anything. It just like continues with success. There's no error, but that's good because we want it to be an idempotent operation. Um, the other thing to note is that this is connected to an Azure subscription context. So it is important to note that within Azure DevOps, you can also set up these things called service connections. So in this case, you can see here, I have a service connection. Again, I'm not going to show you the gory details behind it, but just be aware that the service connection is a way that you can use a service principal and connect an Azure subscription to an Azure DevOps pipeline. The last thing I want to show you here is that I am using a custom self-hosted build agent for deploying the DAC pack into the database. If you recall from the slides that we just used before this demo started, the virtual network, the database that we are going to deploy into is only accessible from within a private virtual network. So what we have here is two things. I'm going to show you from Azure DevOps how you can register and create agent pools. So in this case, we have an agent pool. This one here, Azure Pipelines, is standard. It comes with Azure DevOps. And this one here, which is called Azure Self-Hosted, is the one that I created. And this is a virtual machine that's running inside my Azure subscription. Let me kind of get to this. And it is the only one that can talk to this private network, this database, which is in the private network. So just kind of tying those two things together in terms of where is this self-hosted agent coming from. So that is kind of the overview of the pipeline. Again, this is a multi-stage pipeline. To know more about this pipeline and in general how multi-stage pipelines can help for SQL DB deployments, please reference this blog post. It is on our devblogs.microsoft.com blog. And it goes into a lot of detail about how Azure pipelines and this capability of multi-stage pipelines can be helpful when it comes to these kind of complex deployment scenarios. Okay, continuing on with the demo, the the next thing I wanted to show you was that we already have a starting point in this case, which is the FitnessDB database that we are actually deploying into. And that has these tables. So it has the training session table. Sorry, it has the table because there is only one table in this database. And as you can see, it records certain data. You'll notice here there is no temperature column. And eventually, as you might recall, that's what we want to add to this database, to this table, which is temperature tracking capability. So what we're going to do is, if you recall, we have a SQL project within Visual Studio, which has that temperature column already added. We'll see how when we deploy that, it goes ahead and is actually landing into this database. But before we do that, just to show you the end-to-end kind of picture, this is sample output from that REST API. So the REST API in this particular demo, it happens to be running on the same machine, but it could have been running anywhere else. But the key thing I want to show you is that the REST API, the last record it dumped was ID 3, and it doesn't have a temperature record. It's just having the distance. So our objective is to actually see if the change that we made, which is to add the temperature column here in our SQL project, how does that eventually land into the quote unquote production database in this case? Now I say production, and that means we need to probably have some approvals before we can deploy into production, right? So another key thing in this project, in this pipeline, is that um, you will see, again, this is detailed in the blog post that accompanies this example, but we have a specific criteria saying, hey, this stage, which is actually deploying the database in using DACPack, needs an approval. So we have tagged this particular environment, which is just called production for simplicity, with a requirement saying, hey, if you're going to be deploying into production, you will need approvals. And the way we do that is you use the environments section within Azure DevOps. And if you go to the production environment, what you can see here is that we have an approval requirement saying, hey, we have an approval needed from a person called Azure SQL PR reviewer. This is another user in our Azure DevOps setup. So with all of that in mind, let's actually make a change and see how that lands on the pipeline and therefore into the database. So continuing on, what I wanted to show you next was um, how the baseline looks. So the baseline, as in how this database was originally, kind of deployed. So if you look at this previous run of the same pipeline, you see the three stages that we talked about, and they are very conveniently depicted in a nice graphical way. So the first stage had one job, which is called create DB. Let's take a look at that. So when we click on the individual job, you'll see the different tasks within that job also reflected. And the one that I want to zoom in is this Azure CLI one. So you'll see here that there was a specific set of commands run to actually run into the to log into the subscription and so on. But the most important thing that I wanted to show you is the output. So in this case, we see output, which is actually showing the fact that we created a database using the Azure CLI. So this is very powerful because we can create the database using Azure CLI. The next step is to actually build the DACPack, and we have run this ahead of time just for convenience. So you can see here the build step is actually building the DACPack. So you can see here we are actually running internally. This is just a build, and it generated the DACPack at this location. The second stage in the pipeline also uploads the artifacts that are part of this pipeline. So we'll show that to you in a minute. So let's go back. As you can see here, artifacts are saved as part of the pipeline, and they're very powerful because now I can go back and reference the output, which is this DACPack file, from subsequent jobs, from subsequent steps within the same pipeline. So it's a way of preserving the state across different stages and across different steps in the pipeline. The last thing for the baseline run was you will see here it actually deployed to the database. I'll go back to the approval thing in a minute, but for now let's just focus on the actual deployment step. The deployment step is using that SQL Azure DACPack deployment task, and internally, guess what? It is using SQL package.exe, which is one of the tools. It's kind of the standard tools used to actually deploy to the database. So you'll see here it's performing these actions on the database, and in this case, it has published the database as a starting point. So here's the pull request that we had raised again ahead of time for the change that we're doing. So here again we have a change that is coming in as part of the change. We have adding the temperature, and as you can see, this is just simulated code review comments on saying, hey, why do you want this to be decimal and so on and so forth. So full featured pull request workflow within Azure DevOps. Now this change, this particular pull request has triggered a pipeline. As you can see here, that we have a condition check which is associated with this, which is actually run the pipeline. As you can see from the previous pipeline walkthrough that we did, any pull request will trigger a pipeline. And this build, if you go back here, is currently waiting on approval. So one approval is needed. What we're going to do is, and this is kind of the important thing, right? From a production deployment point of view, we are saying that, hey, manual approval is needed before you can actually proceed to deploy into production. So um, the approval in this case is going to be done by this other user. So what I'm going to do ahead of time is go back into this. It says, hey, you need to approve this before it can proceed. So I'm going to go ahead and say approve. This is another user which has the ability to actually approve uh, the build pipeline to proceed. So in this case, the deployment stage to proceed. So in this case, the once the approval is granted, within a few seconds, you should see the pipeline will refresh and start proceeding. Sorry, I'm on the wrong instance of the pipeline. Here we go. And as you can see here, it's actually gone ahead and started deploying to the database. And the important thing, again, you'll see here, it's running SQL package, but this is with the changes that we have now introduced, which is, as you can see here, it's saying, hey, we are altering this table, and we have altered the stored procedure. I want to reinforce the fact that we did not create an alter statement for the table. If you go back to the project, the table itself is just a create table. So it still remains a create table. But what happened is when the DAC was being deployed by SQL package, again, given this is the whole declarative mechanism, uh, DAC or SQL package actually figures out that we need to ensure an alter table request internally. So this is very powerful in my opinion, again, because you can do changes to a database without knowing how exactly you need to do them. SQL package will do that for you. Just to kind of close out logically on this, let's go back to the table. As you can recall, this was the baseline state. Let's refresh the state of this database now, and we have the temperature column added. So with that new column added, let's see if our REST API call automatically pulls back the temperature. So in this case, I'm going to run the REST API, invoke the REST API manually using curl, and there you go. So this was test data that we inserted outside of the SQL package deployment, but that's fine for this demo. But the key point is, if I rerun that pipeline again, there would be no change to the database because the changes are already done. So the idempotency aspect of that deployment remains. So hopefully that demo gave you a kind of a crisp overview of how you can do state-based or declarative development and deployment to Azure SQL using Azure DevOps pipelines. Again, as a reminder, there is that detailed blog article that we showed you. So do take a look at it. It'll give you a very good overview of how all this came together. So moving on, just kind of wrapping things up, there are a couple of specific tips that I wanted to briefly summarize, given we were focused on using SQL projects and DAC packs for deployments. Many times it comes down to, when we are doing on deployments, sometimes if you, especially if you're altering tables and so on, you want to minimize the impact of those deployments on production workload. So there are some specific tips here. If you're using DAC packs, be careful about adding columns to the middle of the table because that will trigger a complete size of data copy and then rename operation. So there are some specific settings that you can use in that case to try to minimize the effect of such changes. Another option to keep in mind for optimizing deployments or customizing deployments in general is to leverage something called deployment contributors. If you want to know more, go to this GitHub project, which has more details on how you can develop your own deployment contributors. And these have some very powerful capabilities. For example, some of these, like this contributor here, allows you to override SQL package behavior and always use an alter table, alter column online equal to on whenever you're doing deployments through SQL package. Other tips that we can give you at this time at a high level is sometimes when you're doing deployments, some impact to production workload may be unavoidable. In that case, consider the fact that if you're on business critical or on premium or on even hyperscale, which is uh, having the capability of using read replicas, you could redirect your read-only workload onto that replica. So that way you do not have, obviously you can't do read and write on the replica, but then at least some portion of your workload, which is read-only, could be redirected to that particular replica. Again, with hyperscale, or even with a regular business critical or premium or standard or general purpose tier, you could scale up for the duration of the deployment, and that way you can minimize the amount of time that the deployment takes, and then scale down. With hyperscale, scale up and scale down is very quick, or is more predictable at least. um, and it's a near constant amount of time regardless of the size of data that you have in the database. So we do recommend considering hyperscale if you are frequently scaling up and down for Azure SQL DB. Lastly, a few quick notes on Azure DevOps versus Azure GitHub Actions. I think when I say versus, it's not really a versus. It's just these are mutually they have a lot of overlapping features, and eventually we see, hopefully they converge to a certain extent. They have very similar YAML-based pipeline syntax. They are open source. As I mentioned to you, a lot of the pipeline tasks, which are both in Azure DevOps and in GitHub Actions, are open sourced. Even the runners where they have the actual tasks being executed are shared in terms of their environments, what is available within those VM environments, and so on. And the some of the gaps that were in GitHub Actions, like one of the abilities that we missed in GitHub Actions earlier was the ability to run workflows manually. That has been added, so on and so forth. So a lot of these gaps will go away over time, and we'll see convergence of some sort between the two. Just keep in mind that one thing which is not yet there in the Azure DAC deployment task within Azure DevOps, and it's not there in the SQL action within GitHub Actions, is the ability to use managed identities. So this is something of a desired feature that hopefully at some point in time we'll have contributed. But for now, you will have to use SQL authentication to authenticate to the SQL database from within either of these platforms. One last thing, GitHub Actions, I mentioned again, has very similar capabilities, very similar YAML workflows. Um, this is one way that you can use GitHub Actions to build SQL projects. So you can build a DAC pack even within GitHub Actions. And the way you do this is you use MS Build, which is available as part of GitHub Actions. And there's a specific way that you use those actions. So this sample workflow is actually going to build and upload an artifact. So the key message from this is that it is not necessary that GitHub Actions is only for certain types of change-based migration based projects. It can also be used for declarative database deployment, just like we would do with SQL package and Azure DevOps. Another bonus demo, because it's too long, is not part of this presentation, but if you're interested, there is a very similar flow, but we implemented it using something called DBUp, which is a third-party library, open source, fairly popular for doing change-based migration, and using GitHub Actions instead of using Azure DevOps. You can view this demo on your own time if you're interested at this link. So with that, we kind of wrap up, and I want to summarize some key takeaways. As I mentioned early on in this presentation, it is meant to be a breadth view, a broad view on what's out there in this landscape of implementing DevOps for Azure SQL. There are so many options out there, as you've seen, and certain first-party tools that we provide, like Visual Studio, SQL Projects, Azure Data Studio, Azure DevOps, and GitHub Actions fully support Azure SQL. Even if sometimes the label will say SQL Server, it's equally possible to use those with Azure SQL as well. You also saw a lot of options there to protect secrets, have a lot of parameterization, support for complex workflows, approvals. Multi-stage pipelines allows you to do a lot of that within Azure DevOps and so on. So hopefully you got a gist and broader perspective of all the options available to you. I am available for questions after this, and as I said earlier in the presentation, please feel free to contact me on Twitter. I am always there to follow up and answer any questions that you might have. So with that, I thank you for watching, and I leave you with a bunch of references. These are in the slide deck as well. And I'd like to say thank you to all of you for attending, and it was my pleasure bringing this topic to you. Once again, thank you. Do give your feedback, and I again appreciate you for your time today. Thank you.